All right, trigonometry function. Okay, so we're gonna review trigonometry function in this video. There are two ways that you can approach to study the trigonometry. Um, One way is using the right triangle. The other way is using the circle. Okay, the coordinate point on the circle, but we still need to draw the right triangle on the circle in order to get the trigonometry, the ratio of the trigonometry. So definition of sig trigonometry, one thing you should keep in mind what trigonometry actually is actually the ratio between the side length. And trigonometry can help you to find the angle between two side lengths. Okay, so that is the main thing of the trigonometry function. So there are six of them. If you remember the first three, the last three, it just follow the first three and the reciprocal of that. So sine, cosine, and tangent is the main three trigonometry function that you need, right? So sine is stand for opposites over hypotenuse. So let's say you have a right triangle and your angle right here, then whatever opposite to your angle, by looking at that side, this is going to be your opposites. And the one that next to the angle, this is going to be your adjacent because it next to it, so it's called adjacent. Or you can just write an A for stand to that, or you just write ADJ. So it's up to you. And the longest side length, the one that is length, is called the hypotenuse. Okay, so you have three side lengths in one triangle: adjacent, opposites, and hypotenuse. So the trigonometry will represent the ratio of these side lengths. Oh, what is the ratio if I take opposites over hypotenuse? That's gonna equal to side theta. Okay, so side theta is equal to whatever you have for opposites over hypotenuse. Cosine theta is adjacent over hypotenuse, and tangent is opposites over adjacent. And the last three trigonometry is called cosecant. Cosecant is reciprocal of sine. So sometimes you may see sine theta equal 1 over cosecant theta because they are reciprocal of each other. Or cosecant theta is 1 over sine theta. So they're going by pair. And cosine theta is 1 over secant theta, and secant theta is equal 1 over cosine theta. Similarly, we have the last pair is tangent theta is equal 1 over cotangent theta. And cotangent theta is 1 over tangent theta. Okay, so these are go by pair, so they are always the reciprocal of each other. Okay, so even though if you use the circle to define the trigonometry function, it's going to be the same thing. So the circle right here, you don't have for the side theta, you don't see the denominator because this is stand for the unit circle. The radius is actually 1. Okay, so this is unit circle. The radius or the hypotenuse is always equal 1. Okay, so when the hypotenuse is equal 1, so think about it, sine theta is opposite over hypotenuse, and your opposite side length is actually y. Your adjacent is x, then opposite is y over the radius is 1, so that y is equal 1. So sine theta in the unit circle is actually equal to the y coordinate, and cosine theta is actually equal to the x coordinate. Tangent theta is the ratio of the y and x. So tangent is y over x, or just like rise over run. Okay, so it's because tangent is stand for the just like the slope. Okay, you can think of that. And cosecant is just the reciprocal of sine. Secant is reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay, so there's some identity that you may want to remember as well because of the reciprocal relationship. Tangent theta can also written as sine data, not the reciprocal relationship, is because of the definition. Tangent is y over x and sine is y cosine x. So we can write tangent is sine x over cosine x. And cotangent is the reciprocal of that. So cotangent is cosine theta over sine theta. Okay. The theta is just the angle. All right, so these are the identity you may need, some basic identity. Of course, we're gonna have more because this is the unit circle. So we also have something in the right triangle. Isn't that you're gonna have x squared plus y squared equal 1, or r squared, and r squared is equal 1, right? So from this identity, it turned out to give you some more identity of the trigonometry. I will introduce it later on in the before we doing the proving identity. Okay, so now let's use the triangle definition of triangle to solve the example 2. So at a distance of 200 meters, the angle of elevation to the top of a building is 70 degrees. Approximately how tall the building is. Okay, so when you solve this kind of problem, of course, its drawing part will be it will help you to visualize. Okay, so when you do your homework, I would like you to draw out the problem so you can have some critical thinking on that. Okay, so let's say this is the building. So at a distance of 200 meters, okay, so 200 meter, the angle elevation. So let's say you stand at this point and you look up to the top of the building. So this is the angle elevation. It's 70 degrees. So you look up about 70 degrees, you will reach to the top of the building. Okay, and now how much the top of the building is? I'm gonna call that as an x. So how do I find the x? So when this is the case, whenever you have the application that form a right triangle, we're gonna use the trigonometry. Okay, so if you notice that the angle is 70, x is just like the opposite of the building of the angle. Opposites. And the 200 meter is the adjacent, right? So in which trigonometry, among the 6 trigonometry function, which one have the opposites and adjacent? It looks like tangent is the one that involve opposites and adjacent, right? So we're gonna use tangent function in order to isolate this problem. So we're gonna have tangent theta is opposites over adjacent. Okay. And do we know the angle theta? Yes, we know that is 70 degrees. So tangent of 70 is equal. What is my opposites? I don't know what opposites is. So I call that an h. And my adjacent is 200. So I divide 200. So isolate for h by multiply both sides by 200. Cancel this out, we will have h is equal to 200 times tangent 70. So at this time, we will have to use calculator to evaluate how much that approximately. So 200 times tangent of 70, which is 244.39 meter. Okay, so when you do the calculator, make sure you check your mode is in degree. I have the wrong answer right here because the mode is actually in radian. So I have to convert that into degree. So I make that become degree mode. And then now I go back to calculate again. And the height of the building is actually 549.495 meter. Okay, so it's very important when you are doing the application problem. So when the angle is in degree, make sure the mode is actually in degree mode. Okay, and that's gonna be the answer for the height of the building.